At the activity 8B on page 98 and 99 of the textbook, graphs of motion. Now just a reminder, here is a velocity time graph. Always check when you see one of these graphs that it's either velocity or displacement. This is a velocity time graph, and let's just remind ourselves of a few things. One, the slope of the graph is the acceleration. So here's a positive slope. Acceleration is a positive amount. For this flat section here, the slope is 0, the acceleration is 0. Here it is, we've got a negative slope. That means the acceleration is negative. So positive acceleration, no acceleration, negative acceleration of a size that's smaller than this one. This is steeper than that. Positive and negative, this is steeper, so it's got a higher acceleration than that. And number two, the area under the graph is equal to the distance travelled, displacement. Now when we find the area under the graph, we don't easily find the area under an irregular shape, so we tend to have to divide it into either triangles or rectangles, or in this situation here we've got a shape like this, three sides here and this fourth side, in which case we have the average height, this height plus this height over 2, average height times the base length. So area of a triangle, half base times height, area of a rectangle, base times height, area of this shape, it probably has a name, I don't know what it is the average height, this plus this over 2 times the base. So that's our basics there. Now question number one. This graph shows the velocity of a 50 kilogram mass and how it varies with time as it travels along a frictionless air track. It's fired from a launching device, and at the far end of the track a spring brings the mass to rest and returns it towards the starting point. What's the acceleration during the first 2 seconds? So let's look at this, shall we? Let's check velocity time. Okay, it is a velocity time graph. It starts out at 0 velocity. After 2 seconds it reaches a velocity of 10 meters per second. It continues at 10 meters per second for the next 8 seconds, and then it very quickly slows down to 0 and the velocity becomes negative. So clearly it's speeding up, travels away, comes back, etc. So question, what is the acceleration during the first 2 seconds? 1a, acceleration is equal to change of velocity over time. So the change of velocity in the first 2 seconds, it goes from 0 to 10. The change of velocity is 10 divided by the time, 2 seconds. So the acceleration is 5, 10 divided by 2, 5 meters per second in seconds, units meters per second squared, number one. And also you can see that answer is the slope. The acceleration is the slope from 0 to 2 seconds. The slope is the change of velocity. The slope is delta y over delta x. Delta y is 10, delta x is 2, equals 5 meters per second squared. So we can either look at it from change of velocity 10 minus 0 divided by time, or we can just look at it, say, what is the slope of this line, delta y over delta x. 1b, how far does the mass travel from the start of the launch until it first strikes the spring? So clearly this is the mass being shot out at the end of the air track, and here it's travelling at a constant velocity along the air track, and it meets the spring here, it starts to slow down. So the question is, how far does the mass travel from where it starts to when it hits the spring at this point. So we want to find out how far this went in this amount of time. We need to find the area under the curve, area under the graph. So what is the area here? Again, we have to divide into two. We'll find the area of this triangle, then we'll find the area of this rectangle here. So the area of this triangle, area is equal to half base times height, a half times 2 times 10 is equal to 10 meters. Area of this rectangle, 8. Don't be doing 10 there, but it starts at 2 seconds, so it's 8 seconds long by 10. So the area of the second part is equal to 8 by 10 equals 80 meters. So the total area, the total displacement is 10 plus 8 is 90 meters. That's the answer there. C, what is the average speed during the first 10 seconds? What is the average speed during the first 10 seconds is equal to the change of displacement divided by the time taken. The displacement as it travels 90 meters divided by the time, 10 seconds. So the average velocity is 9 meters per second. Again, make sure our units are correct. Displacements are in meters, velocity is meters per second, average velocity 9 meters per second. Okay, number 2, we've got a graph here. Look at it in your textbook. A velocity time graph is shown for a car and a motorcycle travelling on a racetrack. At t equals 0, the car and motorcycle together at the same point. So we've got our graph. And again, check the axes. Is it velocity time or is it displacement time? Ours is a velocity time graph, and we've got we've got one of the vehicles travelling like this, and the other one travelling like this. That's what we're going to look at. A velocity shown, a car and a motorcycle travelling on a racetrack at t equals 0. They're at the same point. Graph A shows the velocity time graph of the car. Graph A, the velocity time graph of the car is this one. This one. What is the acceleration of the car at time t equals 5 seconds? What is the acceleration of the car at times t equals 5 seconds? It's this point here. Remember, acceleration is the slope of the velocity time graph. So what is the slope of this line here? The gradient of that line, let's see, delta y over delta x. The acceleration at 5 seconds is equal to slope 20 divided by 10 is equal to 2 meters per second squared. Check your units again. 2a. 2b. What is the acceleration of the car at t equals 25 seconds? 25 seconds is this point here. Again, on a velocity time graph, acceleration is the slope. So let's see the slope, it's this divided by this is equal to 30 divided by 10, and the slope is negative. Positive slopes, negative slopes. Slope is 30 divided by 10 is equal to negative 3 meters per second squared. 2c. How far does the car travel in 30 seconds? How far does it travel in 30 seconds? Remember that on a velocity time graph, displacement is the area under the graph line. So the displacement is equal to this total area here, and again we're going to have to divide it into 3 sections and calculate the area under this first figure, this first shape under A, the second shape and the third shape. Area under the first shape, area of A, is equal to the average height, 10 and 30, 10 plus 30 is 40, 20, the average height is 20 times 10 times base is equal to 200 meters. The area in the second area, base times height, 10 by 30 equals 300 meters, and the area of this third triangle, 1/2 base times height, is equal to 1/2 times 10 times 30 is equal to 150 meters. Add them together, 450, 650 meters. So how far does the car travel in 30 seconds? 650 meters. The straight line B, that's this line here, the second line here, the straight line B represents the velocity time graph of the motorcyclist travelling in the same direction. At what speed will the motorcyclist be travelling the moment the car comes to a stop? So let's look at the car. The car was this first line here. At what point is the car travelling at 0 velocity again? Velocity started at 0, the velocity started at 10, travels along here and ends up 0 here. So at what speed will the motorcyclist be travelling the moment the car comes to a stop? The car comes to stop at this point here, this point. At what speed will the motorcyclist be travelling? This is the motorcyclist here. At what speed will the motorcyclist be travelling? We don't see this line continued up to this point. If it was to continue accelerating at the same rate, what would be its velocity at this point at 30 seconds? We can see that it's its acceleration is 1.5 meters per second squared. We can see in 10 seconds it increases its velocity by 15 meters per second. A further 10 seconds it increases its velocity by 15 meters per second. At the same rate, we would expect in the next 10 seconds to increase its velocity by 15 meters per second, and it would take it then from 30 to 45 meters per second. So that's 2D, we'd expect it to be 45 meters per second. Its velocity. 2E, will the motorcyclist be ahead of the car, behind the car, at the same place as the car at the moment the car comes to a stop? Where will the motorcyclist be when the car stops? We can see the car at 30 seconds has travelled 650 meters. We now need to say how far will the motorcyclist have travelled in 30 seconds. So we need then to calculate the area under the line for the motorcyclist at 30 meters, and it's this triangle here. 1/2 base times height is equal to 1/2 times 30 times a height now of 45, which equals 675 meters. So after 30 seconds the car's gone 650, the motorbike's gone 675, so the motorcyclist is ahead. Motorcyclist ahead. There you go. That's and we'll come back for the next one in a moment. We have another velocity time graph here where we can see something starts here with 0 velocity. Over 3 seconds it increases to 9 meters per second. Over the next 3 seconds it continues at 9 meters per second. Then from 6 to 12 seconds the velocity decreases from 9 meters per second down to 0. calculate the average velocity over the whole 12 seconds. And let's say, that's our equation, the average velocity is equal to the displacement divided by the time taken. We know the time taken is 12 seconds. We need to find the total displacement. We can't just read it off again. This total displacement is equal to the area under the line, so we need to work out this area here. We need to divide it up into 3 sections. This first section is a triangle, the second section is a square, the third section again is a triangle. So let's look at the areas there. The area of A is equal to half base times height, half times 3 times 9 is equal to 13.5. Area under a velocity time graph is displacement in meters. Area of the second area, the square, base times height, 3 times 9 equals 27 meters. Area of this third triangle is equal to half base times height equals a half times, make sure you don't say, oh, this is 12, it's actually only 6. The base is 6, half base times height of 9 is equal to 27. So the total area is equal to 13.5, 40, 67.5 meters. So we now have the total displacement, 67.5, divided by the time, 12 seconds, so the average velocity is equal to about 5.6 meters per second. Draw the corresponding acceleration time graph for the motion. Acceleration time graph. So now we have acceleration, that'll be in meters per second squared. Acceleration time graph, it's going to be over the same time, it's going to be 3, 6, 9, 12 seconds, time in seconds, acceleration meters per second squared. Draw the corresponding acceleration time graph. Acceleration on a velocity time graph, acceleration is the slope. So we've got a constant slope the first 3 seconds, and the slope is 9 divided by 3 is 3. So over the first 3 seconds our acceleration is going to be 3 meters per second squared. For the first 3 seconds the acceleration is going to be 3 meters per second squared. Then for the next 3 seconds, from 3 to 6, the velocity is not changing, the slope is 0, so the acceleration from 3 to 6 seconds is 0. 0, acceleration 0. Then for the next 6 seconds, the acceleration becomes negative. The slope is negative, and the slope is 9 divided by 6. The slope is negative 1.33. Negative 1.33. So there's our acceleration time graph corresponding to this velocity time graph. That was 3b. 3c. If the object has 0 displacement at time tz, draw the corresponding displacement time graph for the motion. Okay, now displacement time, displacement in meters, time graph, it's going to be the same time frame, 3, 6, 9, 12. Displacement, we see here that the acceleration is constant. That means the velocity is increasing. So we will draw it somewhat like this. The velocity initially might start out small and the velocity increases for the first 3 seconds. From 3 to 6 seconds the velocity is constant, so the slope is constant, and then from 6 to 12 the acceleration is negative, so the increase in speed is going west, so we're going to see it curve this way. So there's our displacement time graph for that. So that's 8b. There'll be another video on 8c coming up shortly. Thanks guys.